quite likely the most efficient introduction I've ever had.
People usually have intro slides, right?
My adrenaline's still going. I've just flown in from Queenstown. I had a fantastic few days. Thanks for asking. It was amazing. So I'm still going off the adrenaline of wondering whether I'd even be able to get here on time. So thanks for sticking around.
Well done.
Or something like that. Thank you. Hi, my name's, let's just skip onto this one. Hi. I tested my clicker to make sure it worked, and last time it worked, but only in really close proximity to the receiver, which makes a clicker really useless. Anyway, it's going well so far. Hi, my name is Ben. I'm not actually an Australian, I'm British, but I'm from Melbourne. But I love New Zealand so much that every time you opened up last year, I came over. So as soon as the hills were open again, I thought, you know what, time to head back over again. It's really awesome to be here. Thanks for joining me. The information up here is not so much grandiose kind of, hey, look at this amazing guy, but just to point out that I'm a developer as well. I'm a developer advocate at Auth0, and sometimes the whole what is a developer advocate can come across a little bit like unsure of the background. So I have been a developer for 22 years. I should probably update that screen. I think it's now 23. I'm getting old. It's a PHP background predominantly, but I also got into front-end development about 12 years ago. Systems analysis and business analysis and that kind of stuff in between before I started working as a developer advocate for Auth0, which basically means they paid me to come around and have chats with awesome people like you. So thanks for being awesome. Anyway, what I actually want to talk to you today is about identity and authentication. And as you might have missed, because I went on very quickly from the opening slide, how we're going to hack JSON Web Tokens. Who here is familiar with what a JSON Web Token is in general terms? Who here has seen a deconstructed JSON Web Token? Who has constructed one manually without the base64 your own code function? You're lying. You're not. We'll dive into what a JSON Web Token is for those of you who put your hand up. And the first question that's totally fine for those of you who have used them a lot. Hopefully, there'll be a few things in here that make people get scared about using them, and that's also a good thing. Fear is what keeps us on our toes. That's how it works for me anyway. All right, how does identity and authentication work traditionally? I won't go into the whole, this is a basic reflection of the auth code OpenID Connect authorization flow. And I won't go into step by step, but essentially, like the user, this person on the left here, makes some kind of request to a resource, and the resource server doesn't know who this person is. There's this redirect stuff that goes on with the identity provider in the bottom right, and we make sure that the only communication where tokens are passed in this sense are only between the resource server and the identity server, and that happens right at the very end when the ID token, the access token, and optionally also a refresh token gets sent through. And there's a lot of stuff going on behind the scenes that makes that secure, so that if you are the owner of that resource server, for example, that you know that the tokens you're getting haven't been modified as you go through. But the identity token at the top there will be a JSON Web Token. The access token can optionally be a JSON Web Token. The refresh token is never a JSON Web Token. I think I said refresh token in the middle, didn't I? First one, always. Second one, sometimes. Bottom one, never a JSON Web Token. Hopefully. If you've ever seen in the wild a JSON Web Token as a refresh token, come and have a chat with me. I'd love to know where that came from. All right, so JSON Web Tokens themselves. They are used.
Oh no.
Look.
Oh no.
All right. Clicker is having lots of fun, so let's go to the top and stuff. I'll just do the whole clicking the right button instead. Mental note. That's happened to me twice now. Not the whole automatic clicking thing. That's new. I need a new thing. All right. So JSON Web Tokens are really good for passing around claims. The claim is basically when somebody says, "My name is Ben." That's my claim. You have no idea whether or not that's true. That's my claim. That's all a JSON Web Token allows you to do is pass these claims around. Maybe it's your user ID. Maybe it's your email address. They're just claims. The recipient can detect data tampering though. So I could create a whole lot of information, a whole lot of claims about myself, and I can pass it to somebody. I might pass it to you, and then you go and you fiddle with some of the data, and then you pass it on to somebody else. And they've got no idea that my name is not actually John, it's actually Ben. So there is a way in JSON Web Tokens to make sure that manual in middle attack cannot happen. I've often wondered, I go into asides a lot, I'm sorry if I go over time. The term man in the middle, when we look at the political correctness and equalitarian aspect, I've often wondered to myself, what is the correct form of man in the middle attack? Does anybody know? It's man in the middle attack, because only men would do it. It's ideal for looking at somebody's identity or a set of authorized permissions. This is where the access token comes in. This is where authorized permissions are. I like the idea of like the permission slip you used to get when you were in high school and you had to go to see another teacher or something, but you have the hall monitors or the prefects. Was anybody here a hall monitor or a prefect in their school? Excellent. I can deride them. Being recorded. I probably shouldn't do that. But yeah, it's basically taking the permission from the teacher and having a piece of paper that says this teacher has given me permission to go and see another teacher. In fact, words missing, but essentially somebody giving you that permission and you're taking somebody else's permission in order to make an action. That's where the access token's going. And we don't really go into refresh tokens here, but in the scenario where you have a refresh token, because access tokens and ID tokens have expiries, if you've got a mechanism where you have a system that's talking to a third-party system and you've got this access token to make these requests, eventually that token is going to expire. And then you'll need to use it to log in again and create a new access token and provide that to your system. So what a refresh token allows your system to do, and this is what we call offline mode, is an offline mode scope. Again, lots of words that don't actually matter right now. But essentially it means that you can use that refresh token to go back to the identity server and say, hey, my access token's fine now, can you give me another one? And then you get another one. Refresh token. So this is what a JSON Web Token looks like. We have a header, we have a payload, and we have a signature. For those of you who were either lying before or can actually base64 URL encode and decode in your head, you will recognize the first two there as being JSON. Phil's laughing way too much. The bottom one you will also recognize as not. And the reason you can work this one out, I mean, other than the fact there's a dash in there, which I don't think will ever come out of base. I can't base64 URL encode in my head, so I don't know whether you can't get a dash out, but I'm going to assume. But also you'll notice the EY input first, that's the brace. So if you ever see a string that starts with EY, your brain from now on is going to say, hang on a second, that's probably a base64 URL encoded JSON payload. You're welcome. Signature is not. If we decode these, we'll see that the first one gives us an algorithm. There are many algorithms, and we'll have a look at those later on in the talk. But this one is the HMAC SHA-256 algorithm, which is used for creating the signature of the JSON Web Token. And we've got a type, which is JSON Web Token. Anybody else see the really weird loop here? I'd assume there was a JSON Web Token to decode the JSON Web Token, find the header of the JSON Web Token for it to tell me it was JSON Web Token. If I hadn't made that assumption in the first place, how would I ever have found out? This stumped me for a while, and I think the main reason, and this is something that has come up in a couple of conversations with people who are coming up with the specs, and I haven't seen it happen yet, but you know how when you have a content type, you can have application/data, but you can also have plus addressing in there, and sometimes you can extend it to say this is going to be CSV type of data. I think the idea with this is that you can actually extend the purpose. So you could specify, look, this is a JSON Web Token, but maybe you can say plus access. So this is only an access token, so it can never be assumed or can never be interpreted to be an identity token. I don't know if that makes sense, but I think that's the idea, is that we can overload it. Of course, it's a JSON Web Token. It has to be for us to be able to find that out. But maybe we'll be able to get extra details of what kind of a JSON Web Token it is and how it can be used and for what purpose it was created, things like that. Okay. Payload, similarly, JSON decoded, base64 URL decoded gives us a JSON blob. This here is an example of some of the data you might find in an identity token. The most interesting one here for you as developers is probably SUB. If you're using a third-party identity provider, whether that's Auth0 or any other, like off-the-shelf or even what's the open source one? Anyone?
OpenID.
Keycloak. Keycloak. It's probably the most common one, Keycloak, which is, I think, is a .NET project, but it runs as a standalone application. Don't quote me on the technology in the background, but basically you can run your own in your own environment if you want to, and it's all designed up to spec. But SUB is the unique identifier or the subject of the person who just logged in. So whereas at the moment in your database you would have a username and a password, you can take those out and you can just put in the subject. So now when somebody logs in using an OpenID Connect compliant identity provider, you get that subject back. And now when you try and manifest that user out of your database, because you're still going to have a user record in your database, because that connects to, I don't know, if you're a banking application, that connects to the bank accounts and the statements and the transactions and the all the other things. So you still need that user record, but now you just store the subject in there, and now you can load the user out based on that subject. Got a name, IAT is issued at. There are things like EXP for expired. There's a lot of 3-character ones which are specified for use in certain ways, which are best not to clobber. Being JSON, you can.
Sorry, what is IAT?
Issued at. The time that the token was issued.
Oh, the time. Oh, and
Yep.
is that in that?
So that's an epoch timestamp.
Yeah, the timestamp.
Yes. So now let's have a look at how the signature works. So the first example we saw of the header had HS256 as the hashing algorithm. It's HMAC SHA-256. You don't need to know a lot about hashing algorithms, but essentially you've got 2 big groups of hashing algorithm types. You've got what we're looking at now, which is the synchronous hashing algorithms, where you have a pre-shared key. So the way that works is you pass in, or you generate some kind of pre-shared key, and you'll see that they're both the same down here. You use a pre-shared key to encode the data, or to create the signature, rather. And in order to take that, to get that, we base64 URL encode the header that we had. So that takes us back to the EUI, whatever we had originally. Separated with a dot, we base64 URL encode the payload. We take that long string, and then we pass it through the HMAC SHA-256 hashing algorithm and pass in the secret. My next bit of advice to you is never use the pre-shared key secret. That's the pre-shared key. On the other side, we have an example of an asynchronous hashing algorithm, which is the RSA SHA-256. If you saw that in the header of a JSON Web Token, the RS-256. And into that, again, you take the header and the payload, and you base64 URL encode them, and you separate them with a dot. And you pass in a private key. The way public-private key encryption and signing works is if you want to encrypt something, you use the public key, because then only the owner of the private key can decrypt it. Signing is the other way around. You use the private key to sign something because only the person who created it can sign it. And then you can use the public key to verify that signature. And that's what happens here. We generate the public-private key. The private key only ever stays on the identity server. The private key can be seen by anybody. And whoever has access to that cannot duplicate, cannot sign an RSA SHA-256 token. So in some ways more secure, but also asynchronous signing is a lot more CPU intensive. So there's timing issues, the data is longer, so there's also payload sizes issues. We'll look at those in a second. So let's have a look at how we can hack JSON Web Tokens with all that information that we have. And there are 4 main
I'm not
types.
feeling confident
That I'm going to be able to hack them, or
that I'm going to be able to hack it.
You will. And there's-
By the end of this
you can even- so I've got a demo, and we'll jump to that very soon. But it's actually like I created this. It's really badly coded. Okay, I say I'm a developer. Don't judge me on my code. But if you go to hackingjwts.com, you can follow along. We'll try it out later. So four types of hacks we're going to have a look today. First one is oopsie, and this one is very depressing. It's when you don't even check the signature.
Okay.
And you might think, yeah, that's not going to happen. Well, it could just be oversight. It could also just be a bug. I thought to myself, I can't just leave this slide as this. I've got to give some kind of evidence for this, right? So I did a search for JWT signature not checked. And there are 145 issues in GitHub, the first one being for an OWASP application. Now, I'm not going to say that actually is a vulnerability. It just means that somebody's raised an issue saying it's not checked. But also, I didn't check for JWT signature. That's a mouthful, isn't it? Ignored, or overlooked, or not used. There are going to be a whole load of issues that come up that may or may not actually be issues, reported issues or not issues. I'm not going to make that assertion. But it certainly has happened. I've spoken to some people at events who've come up to me after its talk and said, I've actually seen this in production. So yes, I've seen a few heads kind of go down. I'm a little bit sad about that too. But it happens, right? Software engineers aren't infallible. So here's an oopsie example. And this is usually where I take a swig of water, but A, I don't have one, and B, I don't fancy taking my mask off right now. So I'm just going to go silent for a while you have a look at this code and tell me where the oopsie is. Oh, the little one got it. That's right.
Oh,
Well, this is the oopsie you were referring to previously, right?
Yes.
Mm. So,
So the little one outside was correct. It is on the third last line.
yes.
Token part 2 is being assigned to the signature, which is always going to come out
I'm
as
not
truthful.
feeling confident.
Repetition builds confidence. It's okay. Yeah, so we're checking the signature. We're doing all the right parts, and we're saying right to the end here, if the signature can be equal to this,
Hmm.
and the application goes, well, of course it can. Here you go. And then we just return token part 1, which is the payload. Yay. So simple things that even, I mean, I'm sure some of you probably spotted it, some of you didn't. That's not an indictment on your ability to build spot code. That's just an example of how bad brains are at spotting bugs. And that's the issue that we have here.
I assumed it was going to be what you were referring to before, so it would be in that bottom line.
Yes.
But as I said, I'm not feeling confident that I can become a hacker.
We have time. Okay, are you still experimenting? Development and testing capabilities in production. Has anybody seen any kind of development or testing capabilities leak through in production? Getting a couple of nods, a couple of hands up in the air. It happens way too often. Some examples could be whether or not the supported hashing algorithm or whether the hashing algorithm used for the token is supported.
Mm.
So these are the examples of the most common 13, I think, if my brain's 14 hashing algorithms. We've got various different key lengths, 256, 330, 384, 512, and various different hashing types, the actual algorithms themselves. Can anybody suggest what might go in the blank spot? I'll go to this gentleman on left here.
none.
Scarily, you're right. Would you like to have a JSON Web Token with absolutely no signature whatsoever? Sure, that's in the spec. So an absolutely correctly implemented version of a JSON Web Token validator would allow a JSON Web Token that has no signature through if the header said none. Is that in production?
Is this whoopsie number 2?
This is whoopsie number 2.
Yeah, just checking.
Yes. So here's not the first example because my name is not John Doe, but here's an example of a JSON Web Token. And you could come along and say, you know what, I want to actually add in admin is true here. But by virtue of adding that in, that's a really bad color contrast bin. By virtue of adding admin is true into this line here, suddenly the signature is no longer valid because the payload has changed. Therefore, when you take the header and the payload and you hash it,
That's true.
the signature doesn't match the signatures in the JSON Web Token. So what you could do is you can try and re-sign it, which is with HS256, you could do that if you knew what the pre-shared key was. If you don't know that, what's even easier is just change that to none and get rid of the signature altogether.
Oh, gosh.
Now, if you want to do this, one thing to note is that when you actually see the JSON Web Token, it doesn't look like this, it's all encoded. It needs to end with that dot, because the header, the payload, and the signature are separated with dots. It has to end with a dot, and then it has to be nothing else after it. The dot has to be the last character. You can't include a signature and say none, because a correctly implemented JSON Web Token validator will say, well, that's not valid, because you said there's no signature, but you've provided me one, so I'm going to break. So make sure you take it away completely. And by saying that, I mean when you're testing and in development situations, right, not in production. That's exactly what I was just saying. So make sure it's got a dot, and the signature is absolutely blank. So one thing to learn from this is that the entire JSON Web Token is actually user-supplied content. Even though it gets passed through in the header, there's no reason why you can't craft a curl URL or use something like Postman to create this. You can change that to whatever you want. You can even just go into DevTools in your browser and modify it there and do a resend. So it's all user-generated content. So treat it the same way as you would any other data that somebody's passing into your website. And hopefully, that's actually more than just trusting it implicitly, which is what we do with JSON Web Tokens a lot. We assume because it's the security thing that's being sent through, we can just take it and trust it and then evaluate it. Make sure we're not trusting it to that extent.
Right, so the man in the middle attack's quite easy on that.
Yes.
Potentially.
Yeah, potentially.
Yeah.
Yeah. Obviously, also, I mean, there's a whole lot of other stuff that's protecting us, like TLS if the connection is going over HTTPS. and man-in-the-middle attacks
Yeah,
are made harder as
there's
well.
lots of security, but maybe there's not.
Multiple layers are always good. It's
Like
like the,
maybe.
the cheese with holes scenario, isn't it? How about breaking the key? Looking at the symmetrical hashing algorithms, HMAC SHA-256, for example, can we break the key? Can we have a weak pre-shared key? Or what if the pre-shared key is leaked? Essentially, this pre-shared key is just like a password, right? It's a word that we use in order to prove who we think we are, whether that's a system or a person, in order to generate or validate a signature. So it can be leaked and can be guessed, and it can also be brute forced in the same way as a password can. Can somebody think of a really scary situation surrounding brute force to do with JSON Web Tokens that is not the same as trying to brute force a password? Do it offline. Because a JSON Web Token is a bit of information that you've got. So you can run on your computer a rainbow table type thing where you go through every potential secret that could be used to generate the signature, and you generate them all. You hammer them out at 1,000,000 miles an hour until they match. Nobody knows because it's all running on your computer. You've got all the information in the JSON Web Token to be able to do that. Yes. There's another reason why I like the asymmetric hashing algorithms. There are reasons for symmetric hashing algorithms. The main one being speed, and as we'll see in a bit when we look at the demo, also payload size of what goes in the header, the entire JSON Web Token. But by and large, one of my recommendations is always to use asynchronous if you can. Now, let's assume that we're using asynchronous. Has anybody heard of an algorithm downgrade attack? There's nothing to do with JSON Web Tokens in particular. It's more to do with going back to TLS and HTTPS. You've got different algorithms for the HTTPS encryption that you get between browsers and web servers, or even servers to servers. And every now and then you'll hear that TLS 1.1 is being deprecated because 1.2 is better and 1.1 has this vulnerability. And there's a way of having a communication with a server during this initial handshake, thank you, process, where you say, hey, here's what I support. And the server turns back and says, okay, well, I'm going to pick this one. You can actually get a server to use an older version of an algorithm if the server has not been properly configured to no longer use it. It'll always use the latest version it can, and most browsers will use the latest version it can, but a downgrade attack allows an attacker to say, I want to try and use an older version of TLS that I know is vulnerable. And the server, if configured not to block that, will say, okay. So this is not a downgrade attack in that sense. That's what a true downgrade attack is. But I'm calling this an algorithm downgrade attack if you consider HMAC to be less potent, effective than RSA, which I think I've kind of half demonstrated so far is probably a wise assumption. Asymmetric signing is always going to be slightly more secure and harder to break than symmetric signing algorithms. So assuming that that assumption is correct, that's a lot of word assumption, assume in one sentence, let's say we're right. We have this shared library. So far we've been looking at single implementations of how we would sign and verify a signature. But let's say we've got this in so many places, we've got so many different applications. They might all be in the same language, but they're on different frameworks and they're in different environments. But we don't want to reinvent the wheel every time we want to validate a JSON Web Token. So we have this shared library. And in there, basically, all we have to do is pass in the token that we've received and the key that we know can be used to verify the signature, or verify the signature of the token. And we'll have a look in the header type, and we'll see that it's going to be an RS-256 hashing algorithm, the more secure one. We like that. So we call our RS-256 decode function, and we pass into it the token and the key, and we return the results of that. If, however, the header says, no, this is an HS-256 hashing algorithm or JSON Web Token, then we're going to use the HS-256 decode, and we'll pass in the token and the key, and we'll return whatever that function returns. Meanwhile, we have a JSON Web Token that we've defined, and again, because this is a more secure system, we don't want people to be able to break our signatures so easily. We choose an RS-256 hashing algorithm, so it's asynchronous. We've got some data in the bottom there. It's John Doe again. He's still trying to become an admin. And we have this little bit of business logic at the bottom. So basically, the thing I mentioned before with asynchronous hashing algorithms, the public-private key pair, I'm not going to say all, but most OpenID Connect compliant identity providers will provide what's known as a well-known URL endpoint with access to JWKS, which is the JSON Web Key set. I always forget the S. It's such a simple word. I want to say server, but it's never a server. JSON Web Key set, which is basically a set of keys in JSON available via the web. So if you go to whatever the domain of your identity provider is, /.wellknown, and you might recognize the .wellknown if you've ever worked with things like mail servers. There's a .wellknown for IMAP and SMTP, so that in the days when we had clients on our desktops, remember desktops, or even on laptops, where you type in your email address and it would automatically work out what all of your email servers were. It would get that from a well-known address. So in the same way here, we're making it really easy. We can go to this one endpoint, it gives us a whole lot of information, including the public keys, which is fine because they're public. So we pull the public key out of there and we pass that down in through the call to decoded token. To decode rather. So the laser pointer should work. Well, that's not going to help the people at home. Although me pointing randomly at the screen isn't either, I guess.
I don't think there's a lot of people dialed in,
Yeah,
so it's just Kick.
Okay.
Yeah, calling it.
So let's step this through. We've got the line at the bottom here, key equals get public key. So we get the key out, we call decode and the token the key. The token we've got somewhere that's been passed into this function. So that calls this part up here. And it pulls in the token and the key. And we have a look at the token header type. The token header type that should actually be algorithm. Gosh, Ben, you're doing well tonight. Let's pretend this word here on the second line at the top there says token header algorithm, and we see that it says RS-256, so we're going to call the RS-256 decode, and we're going to pass the token and the key through. What happens if I do that? So I've just added admin is true at the bottom there. John Doe is still trying to become an admin, but this time signature none or algorithm none is not going to work for us because we don't support none at all on the end there. We throw an exception. But we changed the algorithm to HS256. So now we're using a synchronous hashing algorithm to generate the signature, which requires a pre-shared key. We don't have a pre-shared key. But what we do know is that this line here is now going to get pulled. So what is the key that we're going to be using with the HMAC 256 validator? It's the public key from the public-private key set, which is publicly available. Oh. So let me just walk through that one more time. We're now pulling out a public key, and we're passing something that's available to download off the internet into this function here that we can then use to decode the token, which I'm pretty sure John Doe is going to be able to do, because the number of times he's hacked this, I'm pretty sure he knows about the well-known endpoints. All right. This is where the fun begins. Either that or I start crying because my demo fails. Yeah, what can ever go wrong? So as I mentioned, hackingjwts.com is available for you all to play with if you want. It was written specifically for this demo, so I'm not going to say it's
So you made this.
useful for I made it. Please don't crucify me. If you're interested in the code behind it as well, it's in my GitHub, and I'm happy to share that link. But essentially, it's a way for me to quickly demo how these different things can work, just to make the reality a bit scarier, because we like to scare. So the goal is to log in with the name admin. Let's scroll down. I'm going to crouch for a little. You don't need to see me anyway. All right, so we've got algorithm HS256, name Ben Dechrai, and the signature here. You can see that when I change something here, it changes in the top, so it's hooked up. And if I submit this request, we will get an is admin is false and a status of 200. So that's good because I'm not an admin, and everything was correct. If I then change this to admin, we get is admin is false, status 400, JSON Web Token, error, invalid signature. So this is using a standard library for verifying JSON Web Tokens. And I think you can already guess that one of my other closing suggestions is always use a standard library for validating your JSON Web Tokens. Don't write your own. But let's have a look at what happens if we. So I've got a couple of little helpers down here as well. So I can generate an HS256 signature again, which will then update this. And then if I submit the request, we get admin is true. So that's what you would want to do. But obviously, nobody knows the password is secret. Way too simple. So let's just change this back to Ben and generate a new signature. Make sure that one still works. Cool. Right. This one is the most depressing demo, I guess. So I've just changed it to code ignores signature. So now if I submit the request, we still get admin is false and status is 200. And if I change the payload to admin, admin is true, status 200. So that was that first oopsie. And again, that code's in GitHub if you want to have a look at that actual implementation. Slightly more interesting is the support algorithm as none. So now if we come in here, we're getting false again because the signature is still the old signature we had for username as Ben. So it's doing the right thing, saying token is invalid. And the only thing that I could do is try and really generate a new HS256 signature and hope that that one works. But as mentioned before, if I get rid of the signature altogether, we're still going to get an error. If we change the header to none, this time we send it through and says, yep, this person can come in. That's fine, no problem. Now, just to make a point, let's say we had algorithm as none, but we still had the correct signature in there. That's going to come back and say, no, that's not right. Even though it's a valid HS256 signature, you never specified that there. So the signature doesn't match up with what you specified the algorithm should be. Which, like, if anything's wrong, you always want to err on the side of caution. He says, saying that none is a thing. That's not erring on the side of caution at all. But, you know, most of the time you want to err on the side of caution and say, if there's something that looks slightly out of place, let's just not let it through. All right, trusting the token header. Let's switch this one back, and we'll insert the, actually I need to change this to RS256, and insert the private key. So copy that down, everyone. As quickly as you can. Hang on, I'll just scroll through so you can see the rest of it. That's an RSA private key. Now, this is the point where the demo might fail, because I know there was a bug in this algorithm actually working properly. It works for breaking, but I can't remember whether I fixed it to work properly. So this is what should happen. And you can see here, this is the example I wanted to mention, how much bigger the signature is when you use RSA or any asynchronous hashing algorithms. It makes your payload, like your JSON Web Token, not just the payload component of it, but the whole JSON Web Token massive. When you consider the JSON Web Token is passed through as a variable in the header, that means that this is being passed through with every single HTTP request that you're sending to a resource server. And even though headers are something that you don't see as a person, when you click on buttons, you only see the URL and the query string and then the response. That's still getting passed to the server every single time. So it's making your request absolutely huge, because in some cases that might be equal to all of the other data that gets sent in. You send in a GET request for /index.php, and then you pass that in as the header. It's probably like 10 times bigger than your original HTTP request. And this expands over time as well, because every request you make and then every additional user that comes onto your system, you're suddenly getting a lot more traffic into your servers, which is going to add overhead in terms of processing time, Apache handling time, but also the amount of data coming in. Like, is that something that you need to worry about? Is there a cap or a throttle or a speed at which you can receive this data? So that's where asynchronous can have a downfall, is the header payload is much like, I keep using the word payload. It is a payload, but it's confusing because JSON Web Tokens have a payload as well. The actual JSON Web Token itself is a lot bigger. So hopefully I fixed it. Yeah, so this is what should happen. Name is Ben Dechrai. We're using RS256 hashing algorithm. If I change this to admin, then obviously this is going to fail. Slightly different error message this time, could not validate the RS256 signature. So what happens if I change this to HS256? Well, that's obviously also not going to work because that's not the valid signature for an HMAC SHA-256 signature. So this is where we now come in and we insert the public key. This public key, the private key obviously should not, you should never have a button on your website saying insert private key. Tip number 5. You should probably also not have one saying insert public key, because that's not the kind of thing we want to be bandying around. But remember, it is public. There's no reason why this should be kept secret. We always assume that somebody has access to that shouldn't, like me. So we're going to generate an HS256 signature using the RS256 public key as a pre-shared key. And quite nicely, the JSON Web Token is now much smaller. And if I submit this request now, we get admin is true and status is 200. Yes.
So sorry, what if you use the asynchronous and then you have the much larger token, you're saying that's more secure, but it's very inefficient?
Yes.
Yeah.
So with the asynchronous hashing algorithms, you have a private key and a public key,
Yeah.
as you would with asynchronous encryption as well. So also known as public-private key encryption. The private key is always retained on the server, which means that only whoever has access to the private key can generate that signature. So it's a lot more secure, whereas in the HMAC 256 example before, on the left-hand side, when we're going through the signatures,
What do people do if they have a really high volume site?
either use a synchronous.
And then they just have to realize they're going to just use heaps of capacity for.
Yeah, it's basically a choice of
security.
one way or the other, and
That's just
that's
really
what
a cost.
that's what any security decision is.
Yeah.
Is
how much you're gonna
what the
spend.
risk versus reward.
Yeah. Okay.
Yeah, and the cost as well.
Then,
In some cases, the cost is financial. In some cases, it's also financial. How many more
Really?
servers do we need? It's always about the money. Cool. So that's hackingjsonwebtokens.com if you want to have a play around with it. And that pretty much, I believe.
So just like hypothetically, say you're using like Amazon Web Services, could you get a big, could you sort of like get a huge bill unexpectedly if you, like, you know, you're talking about.
I'm the wrong person to ask about Amazon Web Services bills because
I just feel like you're
I've been
always trying
bitten
to-
in ways that I could never explain.
They took $70 off me and I don't even know what I did, but they told me it was a free service and I could try it out and then I had to pay $70.
Because at this point that I say no comment.
No problem. Yeah, I was just like, this is a good way for
But,
Amazon
yeah,
to
I
make
mean,
money.
Depending on how you manage your hosting, absolutely. If you're getting,
You're gonna be
and
careful.
it's not just about having bigger
I'm not going to play around
JSON Web
with
Tokens
this
in your
on
headers.
Amazon Web
It's also about just getting surge. Like you could have a PR release go out and suddenly you get 20 million people come to your website in one day.
Yeah.
Even if you don't have any JSON Web Tokens in there, that's still going to hurt you. So yeah, totally. All right, so summary. Some of those 5 points that I mentioned are not in here because they're not all sensible. Don't reinvent the wheel. That's one of the ones that I did mention. Use proven libraries. If you are using proven libraries and you find that they're not quite working the way they should. Words late. As with any kind of open source, and I think I'm kind of preaching to the converted mostly here. But
What are the
take the
proven
code,
libraries?
make the changes, and submit them back into the application. What are the proven libraries is a very good question. There is actually a website. Go away. I don't want to do updates.
They're called How to Not Have Your Tokens Hacked. Yeah.
JWT.io is actually written by a colleague of mine, but it's got information on here about libraries, not just the Auth0 provide, but the whole little community provide as well. You can filter by tech stuff. How many people are PHP? How many are JavaScript? How many are Python? How many are Ruby? Yeah, Ruby. I was hoping that'd be like an influx. Hands up if you've ever programmed. All right, let's go with JavaScript.
Not sure.
So down here you can see 4 different libraries. You would probably want to choose maybe this one because it supports way more of the algorithms. But it'll go through and tell you exactly what algorithms are supported by each library.
None of them support none.
Which one's
Yeah, I should have battled. None.
That's right. I'm going to have a chat with Sam, the guy who owns it, so I'll say, you need to put that in. Every one of them. Done. Right. Actually, it'd be embarrassing if one of them came up. Yep,
Yeah.
we'll do that one for you. Then I'll know what to use to update my demo.
Yeah.
So JWT.io also has a really cool little debugger in it. So you can grab any JSON Web Token, paste it in here, and it'll break it down for you so you can see what the header and the payload is.
Nice.
And you can do signature verification, that kind of stuff as well.
Yes.
Good question. Thanks for allowing me to plug JWT.io. Did I mention JWT.io? All right. Let's see if I can remember how to. Yes. Most of the time when I hit the key combination, I think it is, always goes to the first slide. All right. JWT.io, everybody. A round of applause for JWT.io. Yeah, given changes, always push them back into the library you're using so everybody can benefit from them. All right, it's a bit of a lightning round of JWTs. I hope I've scared you all sufficiently. I'm happy to take any questions. I'm ready to dive deeper into any parts you want. I'm happy to also stop if you want to finish for the evening, or anything in between. But thanks for your time.
Thank you. Questions for Ben?
There's also, so with the public and the private, like the key management, there's also sort of provider system for doing it. Like, do you have to build your own infrastructure for generating and rotating those keys?
It's all built in. So you never actually find out your own private key. You should never need to. It gets, so with Auth0, the way it works is you have one or more tenants. Each tenant will contain things like configuration about your applications and your APIs, and whether you want single sign-on or log in with Twitter or intrusion detection or whatever, like that all gets configured inside. And every time you create a new client representation within Auth0, it'll generate a public-private key pair, and that is then what's used to generate the tokens. Because your tenant, you're containerized. I don't like that word, but it's not using containers. I mean, it might be, but that's not what I mean. But the area that is your login system that you have within Auth0, that's when people log in. That's where they get sent to. So it's all contained in one place. Nothing outside of that system should ever need to know what the private keys are. The public keys are obviously accessible via a well-known URL, but you can also download them from inside the dashboard or through like CLI tools or the API, things like that.
Does that do like auto key rotation, or is that like manual?
I don't think it does auto key rotation. One of the hard things with auto key rotation is pushing the new keys out. So what you generally want to do is generate a couple of key pairs so that you can then stick a number of public keys that you can, especially when you're looking at things like native apps, you push out onto third-party devices, mobile phones, laptops, that kind of thing. You don't want to have to push out a new application every time you rotate keys. For public-private, for HMAC algorithms, for public-private, you've obviously got the well-known, so you can pull the public key in whenever you're running it. You can also get the public key out, though, as I mentioned, because sometimes you have applications that run in sandbox environments that don't have internet access, and they still need to be able to have access to that public key in order to verify the JSON Web Tokens. Good question.
So if we were using your service or Auth0, which does all of this stuff for us, right?
Yep.
But I mean, so then we could still potentially create these risks while using your service?
Yes, because what Auth0 does is it generates the JSON Web Tokens that your application uses. What you
I
can
just
do with
wanted
them.
to check that.
Yeah.
I wasn't sure if you were going to say, just use my product and I'll solve it for you.
I will never say just use my product and I'll solve this for you. What I will say is use an OpenID compliant identity provider, whether that's Auth0 or not.
Yeah,
I like
these are
Auth0,
still,
but there are plenty of
with
other
your
options
product,
out there.
these are still an issue.
The recommendation is to use libraries that are proven by the community as working, rather than in the same way as you're encouraged nowadays not to roll your own crypto. Don't roll your own JSON Web Token validation. Don't roll your own credit card validation. All of those kind of things. Cryptography, not cryptocurrency.
I learned a
Don't roll your own cryptocurrency either. So that's just a but yes, at the end of the day, what you do with that JSON Web Token, you can totally You could ignore it completely and just say, oh, look, this is a JSON Web Token with Ben's name in it. I'm just going to trust that it's Ben.
Yeah.
Don't do that.
Yeah, I mean, I did some basic training in Auth0, and I was told this is a very complex area that you need the supervision of a very senior person. So, yeah.
Well, I think it's always good to have somebody who knows what's going on somewhat under the hood, which is the main reason why I do these talks. Is like, you shouldn't need to know most of this, but understanding what can go wrong gives you the ability to detect in the future when you look at code thinking, hang on a minute, this doesn't quite look right. For somebody who's just starting out for the first time and wants to get Auth0 running, we've got quick starts that you can download and just get it up and running, and then you know that that's been implemented to the best practices. But it's always good to have that knowledge in general about what security is being looked after for you.
Yeah.
Because we used to have an issue like 10, 15 years ago where we were talking at OWASP meetings talking about how to not allow cross-site scripting vulnerabilities, whereas nowadays a lot of the frameworks do that for us. But some of us are forgetting what that actually means to see a cross-site scripting vulnerability, which means that we could inadvertently introduce them, despite the fact that the frameworks are stopping them. So yeah, it's a intrepid adventurer world to be a developer nowadays. Yeah. Yes.
How does your application know when the token expires?
So the expiry is actually built into the token. So in the example we had IAT, there's one called EXP, and that's an epoch timestamp of when it expires.
So if like in your implementation you didn't have IAT or EXP, so would that mean if someone were to sample the token, they could have?
My example was a cut down version. Almost every token would always have an EXP.
So
if it doesn't have an
standard,
EXP,
it has to have IAT and EXP and all tokens.
Yes. Yeah. If it doesn't have an EXP, then most validators will say this is not a valid token. Yeah. Cool. Any questions from the back as well?
One comment you made previously, like naive attack is protected because of that signature algorithm. So as a pure front-end developer's perspective, if we pay for a credit identity provider, is it just like we receive whatever return from, Azure ID, save it or a piece of code, send it back in a request? Know this without knowing this kind of details.
Sure. So just to rephrase that.
Is it okay most of the time?
So I'll just rephrase that slightly to make sure I understood. So when you use an identity provider like Azure AD or Auth0 and you get a token, can you just take that token and pass it straight onto the API or whatever resource server you're requesting without having to worry anything about it? Yes, that's absolutely fine. The JSON Web Token should never be changed after it's first created. That's the whole point of the signature as well, as to ensure that it's never changed. So you can trust completely that the token you receive is the one that you can pass on. The responsibility is then with the function or the service or the whatever that actually determines whether or not access should be granted to whatever resource is being requested to then verify that JSON Web Token. So you've got the issuing, you've got verification, in between it can be sent anyway, that's fine. You could choose to verify it in the middle as well, so you don't even make the call if the person's not authorized, but you don't have to.
You're just doing that. That's sorry. You were just doing that in the front end. Your secret would be in the front end, and that would be
Well, it depends on what you're checking. If it's an RSA signed identity token, then you could verify it on the front end and make sure the admin is true is in there before making any admin call or before rendering the admin menu or things like that. Yeah, but no, you can't check an HS or a synchronously signed JSON Web Token on the front end. Yeah. Cool. All right. Thanks very much, everyone.
Yeah, cool. Thanks again, Ben. Yeah, thank you very much. Like jumping straight off a plane, hopping in a taxi, and then coming and giving a talk. It's really cool.
I arrived outside, and was that John that I met?
John's just over there. Yeah.
He looked and he saw me with my big bag, and he went, "You'll be Ken."
Yeah, you'll be. So no, we're really lucky with the OWASP Wellington meetup to have you here. So thank you, and again, thanks to Tim for giving your talk too. If you have questions, just talk to them. There's a Twitter handle. You're P Ruby on Twitter, So yeah, you can reach out to people or put a message on the OWASP meetup group.
Yeah.
But yeah, thank you so much for attending and keep an eye out for the next one.
Cool.